Hello everyone. Let's consider this example. In this example, time quantum given is 2 unit. Okay. So for any process, we will, if the process burst time is greater than the time quantum, then we will execute this process by exactly 2 unit of time. Okay. And there are 6 processes given here. Process P1 have arrived at time 0 and their burst time is 4. Okay, process P2 is arrived at 1 unit of time and its burst time is 5. Similarly, process P3, P4, P5 and P6 arrived at the time 2, 3, 4, 6 and their burst time are 2, 1, 6, 3. Okay. So in this algorithm, we used one is Gantt chart and the other is Q. Q data structure is used to denote the processes which are available at the particular time of arrival. Okay, means at let's say we are at a particular point of time. Let's say we are at a time of 10 unit of time exactly, and based on this 10 unit of time, how many processes are available in the queue, and if let's say 2 or more processes are available in the queue, then we will pick the process which arrive in the queue first and schedule it to the CPU. Okay, so let's first draw the Gantt chart. Okay, so it is somewhat complex. I need you to pay full attention here. So first of all, at the time 0, we have only one process, which is process P1, and process P1 have burst time 4 unit of time and the time quantum given is 2. So definitely burst time is greater than the time quantum. So we will execute this particular process P1 for exactly 2 unit of time. So process P1 is scheduled from time 0 and it will execute exactly 1 unit of time quantum, which is 2. 0 plus 2 is 2. Okay. Now this particular 4 is reduced to 2. Why? Because process P1 runs for 2 unit of time. Now the time left is 2 unit. Now at the time 2, how many processes are available in the ready state? The processes are available is P1. P1 we already run it for 1 unit of time. P2 and P3. So process P2 and P3 will come to the queue data structure and we will run this process P1, and process P1 need again 2 unit of time. So we will again put this process P1 after P2 and P3. So remember this procedure. Whenever you run the particular process, first after running this process 1 unit of time quantum, then check how many processes are available. If let's say some processes are available P2 and P3, then put these processes in the queue, and then if process which are run earlier need more time quantum, then we will put this process again. Okay, so the next chosen process is process number P2. So process number P2 is the next process, and process P2 require 5 unit of time, but we have only 2 unit of time quantum, so we will run this process for exactly 2 unit. So 2 plus 2 is 4. Now the time left is 3. So process P2 require 3 more unit of time. At time 4, how many processes are available in the queue data structure? At time 4, P4 and P5. Process P4 is available and process P5 is available. Now this process P2 requires more time, so we will cut this process and again add it here. Got it? Okay. Next chosen process is process number P3. So process number P3 will be chosen next, and it requires exactly 1 time quantum. So we will run it for 1 time quantum. So 4 plus 2 is 6. Now the process P3 requires 0 unit of time, and after the time 6, how many processes are available? There are only one process. left, which is process number 6. So we will add this process and then cut this particular process, and no need to add this process number 3 P3 after P6 because P3 is completed now. So P3 is completed. Now after P3, P1 is again picked. So I have chosen P1 and run for 2 unit of time because time quantum given is 2. So 6 plus 2 is 8. Now process P1 is also completed. So process P1 is also completed. Next process is process P4. So pick this process and run for 1 unit of time, 8 plus 1. One important thing here is, if the process requires less time than the time quantum available, then run the process exactly what it needed. Okay, no need to allocate the more time for the process which requires less time compared to the given time quantum. Okay, so here process P4 require exactly 1, so I will give this 1 unit of time to process P4. So 8 plus 1 is 9 and process P4 is also over, so I will remove it from the queue also. Now after process P4, next process is P5. P5 requires 6 unit of time, but I have only 2 unit of time quantum given, so I will run it for exactly 2 unit. So 6 minus 2 is 4. So here 9 plus 2 is 11. Now we will add this process P5 again because it requires more unit of time. Next chosen process is P2. P2 requires 3 unit of time, but we will give only 2 unit of time based on the time quantum. So P2 11 plus 2 is 13. Now here it is 1 left, and again add the P2. Next process is process number 6. Okay, process number 6 requires 3. We will give it to 2 unit of time. So after giving 2 unit of time, the time left is 1, and here the time will be 13 plus 2 is 15, and again add P6 into the queue. Next process is P5. So select the process P5, and P5 requires 2 unit of time, then the time left is 2, and here the summing of time will be 15 plus 2 is 17. Again add this process. Next process is P2. So P2 requires exactly 1. So 17 plus 1 is 18. Remove this process and it is also completed. Next process is process number P6. Process number P6 requires 1 unit of time. So 18 plus 1 is 19, and it is also over. Now the next process is P5. Process number P5. It requires 2 unit of time. So we will give it, and 19 plus 2 is 21. Okay. And it is also over. So all the processes are completed. Process number P1 to process number P6. Now the next thing to find out is completion time. So before finding the completion time, I will erase this time because it is not needed. Okay, what is the completion time of process P5? It is 21. Completion time of process P6, it is 19. Completion time of process P2, it is 18. Then after P5 is also over. P4 is 9. Then P1 is 8. Then P3 is 6. Okay, and remove the Q data structure here because it is no longer needed here. Now the next thing is turnaround time. So after finding the completion time, we will find turnaround time. Turnaround time is completion time minus arrival time. Okay, so what is completion time minus arrival time? 8 minus 0, 8, 18 minus 1, 17, 6 minus 2, 4, 9 minus 3, 6, 21 minus 4, 17. 19 minus 6 is 13. Next is waiting time. Waiting time is turnaround time minus burst time. 8 minus 4 is 4. 17 minus 5 is 12. 4 minus 2 is 2. 6 minus 1, 5. 17 minus 6, 11. 13 minus 3, 10. So we can easily find out the average turnaround time and average waiting time. So average turnaround time will be, just add this column and divide it with the number of processes available. How many processes are available? There are total 6 processes available here. So we will add the number 8 plus 17 plus 4 plus 6 plus 17 plus 13 and divide it by 6. Okay, so you can do the math easily. Next is average waiting time. Average waiting time is, add this column and divide it with 6. So 4 plus 12 plus 2 plus 5 plus 11 plus 10 and divide it by 6. Okay, so calculate this average turnaround time and average waiting time. Okay, so this is the concept which will be used for solving the numericals of round robin algorithm. Okay, in the next video we will see the other aspects related to round robin algorithm.